All right, so this is the last section in this unit. It's applications of rational equations, which is a fancy way of saying word problems. And no one likes word problems. The reason they're hard is because you have to create the equation which they then have to solve. I'm going to go through these three different types of problems with some examples to try and see like the way to approach these types of problems, because they always have the same general formula. You just need to like rearrange them or put the numbers in the right places basically. So three types of questions. There are speed questions, which usually involve like two people running or moving somewhere, usually up and downstream. There are rate questions, which involve people like moving stuff. Actually, let's draw sweet pictures. It's got like two people running. Look at those zoom lines. Okay. The rate questions is when you have two people working, and they're usually like working together to do something. So you compare the rate of them working by themselves or the rate of them working together as a team, which is faster. The last one is percentage. So this is where you have like liquids or something that is a percentage, and then you mix it with something that is not a percentage. So usually it's like you're mixing like acid with coke or with water, and then you're trying to make something that's like less acidic, less percentage overall. So let's go through each one and see what they look like. So let's read an example over here first so we can kind of see what's going on. Squirtle swims 24 kilometers downstream to a Poca Center, then 24 kilometers against the current back home. The whole trip took 9 hours. The speed of the current was 2 kilometers per hour. How fast can Squirtle swim without a current? So like obviously it's a silly Pokemon one, but the same idea applies with like going up and downstream or like planes flying against a current or whatever. That's usually how these are set up. So the first one, like this was set up, was a total trip. So it was two pieces of the trip added together. So it's going to be something plus something equals something. The way we're going to think of this, I know that the whole trip took 9 hours. 9, that's time, right? So I'm going to use this formula, the speed equals distance time, because when you think about it, like kilometers per hour is speed, right? So that's your basic formula. I want to make it so it equals time though, because I was given the 9 hours as time. So I'm going to use this formula instead. Time is equal to distance plus speed. But like we said, we know there's two pieces. So I'm going to write the distance over the speed of the first trip plus the distance over the speed of the second trip. Now we have to change this because some things are going to be different. When we look over here, it says 24 kilometers down, 24 kilometers back. So that 24 kilometers is for there. That 24 kilometers is for there. So I'm going to change those numbers. So 24, 24. I don't know what the speeds are yet. So let's think. So he goes downstream the first time, and then he goes against the current the second time. When you think of you're going with a current, when you're going downstream, the current's pushing you, it's adding to your speed. When you go against the current, it subtracts from your speed. So I'm going to write the speed of Squirtle, which is S. Let's make it X so you don't get confused. Okay. And then when he's going downstream, he gets that bonus 2 kilometers an hour from the current. But then when he's going back, he gets minus 2 kilometers an hour because it's going against him. Now when we look at this equation, we have enough information to actually solve this. I'm not going to go through the steps of solving because these are just like problems before, but it's written in a way that I could isolate by x by multiplying everything by like x plus 2 and then multiply by x minus 2 to get rid of the denominators. Okay? So that set up that question. There is a variation of this type of question, and this is where you compare speeds instead of adding them. In this one, Squirtle did 2 trips and had a total. It said the whole trip took. In this example, you have 2 people running in a race and you're comparing. When you're comparing, you have to set up your equation a little differently. So in this one, Dude Face and Cool Cat, greatest names ever, are running in a 6-kilometer race. Cool Cat runs 2 kilometers an hour faster. Dude Face finished 1 hour after. Determine their speeds. So I'm working with time, so I'm going to set this up as like a time equals distance speed, and I'm going to set it up as an equation to compare on one side of the equation Dude Face and one side to have Cool Cat. So I know that their speed, so I know that when I'm comparing their times, it was that Cool Cat was 1 hour faster, right? So like let's say that Dude Face did it in 10, Cool Cat would do it in 10 plus 1. Sorry, 10 minus 1 because it was faster. So in this case, I'm just going to leave it. Dude Face's speed is like this. Cool Cat's is like this. But I'm just going to put a big minus 1, which means his total time minus 1 hour would be the same as Dude Face's. Once we have that set up, we just have to put in the numbers. So the distance we knew was a 60-kilometer race. It's 60 kilometers for both of them. Some questions, they'll run different amounts of distance, and these numbers might be different, but this one, they're the same. And then the speeds. I'm going to write it. Cool Cat runs 2 kilometers faster than Dude Face. So I'm going to say Cool Cat's speed is like the speed of Dude Face. Again, we'll call this X plus 2, whereas Dude Face just runs X. It's a good idea to define your variables, because you could have, if you wanted, made it like this, X minus 2 for Dude Face. I think that's just more confusing though. Okay, so X is Dude speed. And again, now that I have this equation set up, I can solve the rest of it. It's just a little trickier because we're comparing two things, kind of like a balance. So you just have to think, what do I have to do to make them balanced on both sides? And in this case, it would subtract that 1 to make them the same. A lot of the questions like these deal with times, so it's helpful to use this formula. But if you want, you can rearrange it. So those were the those were the speed questions. The rate questions almost always involve someone doing a job, doing something. So for example, Mr. K can arrange the desks in 40 minutes, so that's his job, whatever. But then if someone helps him, this is the new time it takes. So the way we're going to set this up is that we're going to think of this as a percentage. So on this side, we're going to say it's 100% complete. It's how long it takes them to finish 100%. But when we write percent, we just write 1. So what we're going to do is we're going to multiply the rate that the person does it times the amount of time they do and add it for both of them. So for this one, this would be Mr. K's rate times the time. This would be the student's rate times the time. So we're going to think of what's Mr. K's rate. Well, he completes one job in 40 minutes. So that's his rate, 1 over 40. The time, we'll do the time in a sec. The student's rate, we have no idea. I don't know what it is. I know he does one job, I just don't know how long it takes him. So I'm going to put that as an X, okay? Which will be like X equals time for student to finish solo, okay? And we're going to multiply by time equals 1. So in this scenario, the time that we're given was actually 24 minutes, because the idea was that if they worked together, when he helps them, when they work together, the job is finished by them completing it in like 1%, 100%. So instead of time, I'm going to write my number as 24. Okay? Now that I have this equation written out, I'm actually able to solve for x, not in not too complicated a way, to figure out the entire thing. There will be some questions where you're going to have to rewrite these numbers instead of like 40 and x, and they'll say instead of like, oh, it took him 40, it's like he is a little bit faster, like he can finish it 9 minutes faster or something, so it'd be like x minus 9. Those type of questions exist, but it'll always be set up this way. Two people working together to complete it 100%. And again, those are working rate questions. The last one, sorry this video is long, we're almost finished. These are percent questions. I'm going to show you 2 ways to set up percent questions. The smart way that makes sense for more situations but doesn't use the learning from this unit, and then the textbook way, which uses the stuff from the unit but only works for certain type of questions. So a lot of questions you'll get will be like this. How much something, like concentrated something, must be added to 2 liters of water, it'll almost always be water, to make 20%. So the idea is like the Coke is 100% because it's 100% Coke. The water is 0%, but when you mix them together, you get kind of like a mixture we want 20%. So the way we're going to set this up, let's do it the textbook way first. The way they think of it is you need the volume of your Coke divided by the total volume is going to give you the new percentage. So your total percent is out of 100, and the Coke wanted 20%. Okay? I don't know how much Coke I need. I'm going to call that volume. But for the total amount of liquid, I know that I had the 2 liters of Coke, or the 2 liters of water, plus I have no idea of Coke. So the total volume is going to be this. Once you have this equation set up, again, you can do your multiplication, cross multiply, to solve the rest of the question. that is the way that it works, but only if you're using water, if you're using something that's 0%. If you're using something that's not 0%, we need to set up a different way. This is kind of like a grade 10 setup. The way that this one would work is you would multiply the percentage times the volume plus the percentage times the volume of the two things. So this is the water, this is the Coke. And then you find out the total percentage times the total volume. So it's kind of similar, but like with different setup. So in this case, the percentage of our water was 0%, and we had 2 liters. The percentage of the final product was 20%, which I'm going to put as 0.2, and the total volume was V plus 2 again. The Coke, I don't know what volume it is, but it's 1%, which I'm going to write as 1. Again, I could have written it as like 120 over here, but then I have to reduce it later. So I just like putting it as 0.2 to make it a little bit simpler. When you do this question, it'll actually work out to the same answer as this. The only benefit of this question is that if you are mixing liquids that aren't the same. So for example, a question might say you have an acid that is 33% concentrated. You also have the same acid that is, let's say, 58% concentrated. How much of each should you combine to make, let's say, like 10 liters of 30% concentrate? 30%. Sorry, that's not the 30, it would be like 45%, something like that. And the idea is that when you know that percentage, you can sub it into the number over there. So you will mostly get these types of questions where you're dealing with water. So if you like this equation better, go for it. Use it. That works. That's fine. And those are the 3 types of questions. Okay? Speed, rate, percentage. You can remember how to set them up. And once you get the equation, the rest of it's pretty easy.